So let me start the. Okay. Yeah. So hi everyone. Good afternoon, good evening, and thank you so much for joining us today. So we are continuing our data structure series, and today we have with us Pavithra. She'll be taking us through stacks. Yeah. So a little bit about Pavithra before I hand it over to her. Pavithra Vasudevan is an application developer with 9 years of experience. She is presently employed with VMware as a member of technical staff. She's a proponent of DEI and is one of the directors of Women Who Code Chennai chapter. She graduated from Anna University with bachelor's in computer science engineering. She has completed her micromasters in data structures and algorithms from UC San Diego. She's a self-driven professional with a passion for discovering new and challenging things in the world. It's so great to have you here, Pavithra, and I'm sure we will go back with a lot of learnings. So I will hand over the stage to you. And yeah, you're not, Pavithra, you're not audible.
Yeah. Hey, thank you. Thanks, Rubanjali. I'll probably start sharing my screen and then let me know once. Is it coming up?
It is loading for me, at least.
Okay.
Yeah, I can see your screen.
Okay. So I guess you can see the slide, right?
Yeah, the slides are visible.
Okay. Yeah. All right. Thanks everyone for joining. So let me quickly start with the session. So this is our third session on Women Who Code Chennai data structures and algorithm series. And we'll be discussing only on stack, and stack is a kind of very, it sounds little tough, but it's kind of very simpler one. So I would like to share whatever I have, I have seen and have gone through. So yeah, so this is the agenda for the day where we'll be talking about what are stacks and how do we represent it, and the key operations that we can perform on stack and the implementation, and a little bit of real-time application, because most of us would be interested to know that part of it, right? So all right. So I think before we get into the technicality of it, so quickly, so if you look at this image, I think this would explain it all on what a stack would be. So generally, as an English term, what we say is stack is something you stack it up. You keep one on the top of the other on a given space, on a confined space, you can say. So here is an example of something like a plate. So if I take this plate as an example, so you can just see this. So we have this green starting. So this is the first plate that I've kept, and then followed by a red, orange, blue, and this one. So here, the very first one which has come at the bottom would be called as the first in, the very first plate that has come in my overall stack. And the last one that has come is my blue plate. So obviously, what will we do? So if we are sitting and we want to take all these plates for ourselves, we would obviously tend to take the very first one on the top, and we don't tend to pull the bottom one, which is risky and it would spoil the entire structure as well. So having said that, I think this would answer the entire image of it. So this is the one which came at the last, and this is the one which is going to go the very first. Similarly, the green one is the one which came very first, whereas this plate will be the one which would be utilized at the very end. So that is the basic structure of a stack, with one more additional thing where you can see that there is something called top. So top is nothing but the very plate. When I say plate, it's a plate, or an object, a variable, it could be a variable. So the one that is on the top, on the the last in, is something called top of the stack. So these are the basic terminologies that we would keep crossing when we talk about stack. So technically speaking, it's a linear data structure, and it has a specific order. Order as in the way it came in, that's its order. And we follow last in, first out, or anything. Both means the same. Last in, first out, or first in, last out. Okay. So I'm moving to the next slide. Okay. So now we'll just talk about the operations on a stack. So when I say operations, I think whatever we spoke about, the push, pop, top, is empty, and size. These are the technical things that we can do on a stack. So imagine we have a set of plate, and what all possible thing we can do. First, there is a shelf, there's a rack, which is empty. So when I give this function is empty, then obviously it will say true or false. If it's empty, it's going to say true. If it is not empty, this is going to give me false. So consider we have an empty rack. And first, how do I push the very first element into this empty stack? I use this function, push. So I say push off and I pass my data here. Data can be a number, a variable, an integer, or it can be anything. It can even be a complex object. But when I decide that I'm going to use this kind of data structure, I would first use this push. So the first object has come in, that is the green plate has come in. Similarly, you keep pushing multiple objects. And then what we do when we have to remove an object, we say pop. So pop is nothing but removing one after the other. So one key thing that we have to remember here is pop will remove an element. So technically, when I apply pop on this set of plates, my blue plate is going to come out and this yellow would become the topmost plate. So technically pop is nothing, but you're literally removing it out from the stack. You can even call it as deleting it from the stack. So something of that sort. Whereas on the contrary, we have a concept called top. So top of stack is nothing but retrieving the topmost element, which means the element is still going to be there. The blue plate is still going to be there. You're not going to pick the blue plate. Rather, you imagine as if you're peeping through the rack and seeing which one is the topmost plate. So here, if I peep through and see what is at the top, I would come back with an answer that blue is at the top. But still, blue is still on the stack. So that's the key difference between pop and top. So pop, if I do on it, I'm removing it literally and something else would become the top. Whereas top of element is just peeping through. So we also have another name to top, which is peek. They say PEEK, which is nothing but peeping through the stack and seeing what is the topmost element. Okay, so that's what is written here. So pop is remove an element from the stack. Top is return the topmost element, which will still be on the stack, but you just pick the element. That's it. And size, it's as usual. So you just say what is the size of the stack? It would be the total number of I would say elements that is pushed to the stack. If you have pushed 5 elements, say 5 numbers, 5 characters, 5 string or anything, your size of the stack would be 5. Okay, so that's the key operations that you can generally perform on a stack. Okay, so we have seen what are the operations on a stack using this plate example. So now we'll see a little bit of technical examples where we'll start with this sequence. So now 1, 2, 3, 4, 5, and 6. So my very first operation is going to be push of A. So A is a character, a single character that I'm going to push into my stack. So when I say push of A, what would happen? My stack gets A. Push of B, it gets A on top of it, it will be B. And push of C, A, B, and C. So I have 3 elements on my stack. So this is how my stack would look like. So now coming to the fourth one, which is pop off. So I think whatever we spoke in the previous slide, now it would make sense where when I say pop off, it would remove the topmost element, C, and give me back A and B in my stack. Okay. So now coming to the fifth one, which is top. So when I go to this stack and peek through and see what is at the top, it is going to be B, right? So similarly, if I peek through and see what is in this stack, what would be the answer? It would be C. So top is nothing but it would retrieve and give you the topmost element. Okay, and it doesn't change the structure of your stack. It remains as is. And the final operation is empty. This empty is like true or false. So since we already have some elements in the stack, it's going to be false. Okay, so this is an example. So we spoke about single stack, and there is another concept called set of stacks, where you can have multiple stacks in a stack structure. Say this will be your first stack, this will be your second stack within a stack. Okay, pushing stacks within a stack. So that is kind of little real time. They use a lot of set of stacks. Okay. I'm going to the next one.
Pavithra, I have a question.
Hey, yeah, sure.
Can you go to the previous slide? So what if I do, like I have come to the 6th sequence where my stack is empty. At this point in time, if I do a pop, what will be the outcome?
No, it would error out. Technically, is empty can either say true or false, right? So is
Right.
empty, you see, say for example, you do a top off or pop off or any operation on an empty stack will throw you an exception. If you use Java, you have to ensure that you catch the exception and then handle it accordingly.
Okay. Well, that is with respect to Java, but for any programming,
Yeah,
any
in
code,
any
the behavior will be same.
yes, it would be the same. So it is just a data structure, right? So this can be implemented in any language of our choice. So this is kind of a concept which is predominantly available everywhere. And depending on the programming language in which we are going to implement it, we have to handle it in the right way. Say, for example, in any case, we have this habit of checking is null, is not null. So this is as good as that. As a good programming practice, what we do is we check if it is empty, and then we do something like that, or we assign certain value to an empty stack and then show it as an empty. So it depends on an individual's choice of programming language and the requirement.
Sure, thanks.
Yeah, thanks. Okay, I'll move on to this representation of stack. So I think in the previous second session where we had a high-level overview on linked list. So this is again coming up here. So stack is something which you can represent as an implement in a couple of ways. And there could be many other ways also, but these are the main, the main ways which we implement. One is you can show it as an array. You can recreate this entire concept of stack using an array, or you can recreate this concept of stack using a linked list. So coming to an array, I think array, it's a self-explanatory thing where we all know, it's like array and you have array has this index 0, starting from 0, you have all these things. And then looking at this array, how do I represent it as a stack? So now your 0th position, whatever is in this position will be your first element, which has come in the very first time, followed by 1, 2, 3, and 4. So the topmost tag, when I say top of, I'll be getting this value, whichever is in the 4th position. Okay, we can just imagine it this way. In the upcoming slides, I'll show you how to implement it. And similarly in linked list, I think the basic concept of linked list is it has a data and a pointer to the next value. So that's how it gets linked with one another. And in our stack case, it would be like the very first element that you push to the stack will be having the head node pointed to it, followed by all these things. Okay. Okay. So I think I'll quickly show the implementation of it. Can someone confirm if you see my programming screen?
Yeah, it is visible, Pavithra.
All right. Okay, so I'll just quickly, shall not take much time in this, but I just want to show the operations that we do and how do we do it in Java for both array and linked list. So I just explain the class. So this is my class, and I have declared a variable of say 1000. So array generally has this condition of giving an array size well ahead. So I'm just saying it's an array of 1000. And then I have an integer for top because I'm going to play around with the integers or something. So let it be top as an integer. And this one, so top is a pointer to the integer, and this is your actual array. So now we'll see how do we implement it, implement our stack in array. So yeah, so this is your constructor where you say top -1. The very first time, like when you peep through, as in when you look at an empty stack, how will it look like? We'll just assign a value, say -1, so that it is a condition for us to see that it's an empty stack. As we progress through the stack, we'll keep changing this value to 0, 1, 2, 3, which is kind of similar to this one. So yeah, this image is the one which we are going to show how to do the coding for. So currently we are outside. We didn't enter the array. We are outside somewhere here with -1. The moment we progress, we start progressing like 0, 1, 2, 3, and 4. Okay. So yeah, so as we saw, these are the operations. So I have declared is empty. So I'll go one by one. Is empty. What do we do when I call is empty? It has to check if it is empty or not. So technically what would happen? I have already said top is -1. So if my top is less than 0, it means it's true. If it's greater than 0, then obviously it's false. Okay, so it's a straightforward step. So now push. And what do we do it in push? So push is the only function, operation where you pass an element to it. You push something. That something is what you give it as a parameter. So you push something. How do you push it? You just have to check if there is an overflow of stack. So what is stack overflow again? It is nothing but if your array has reached its maximum level. So 1000, if I say 1000 is the topmost, you can push up to 1000 elements. You just do all these are generic. So you just do this. And then if it is okay, if it is not a stack overflow condition, then you come to your array, you increment your top. So now from -1, we are progressing to 0. And we are assigning our very first element, the element that was passed. And then all these are general conditions. So this is just to show how do we push it. Push, pass an element and you push it. And pop, you remove an element. How do we remove? First, you have to remove decrement your pointer. So now the top would say 4 elements are there. You have to do a -1. So top -1 and remove the topmost element. When I say my array of top minus, it's going to point to the topmost element. Okay, and it will return. So pop is nothing but returning an element. And when I say return, it obviously means that it's going to remove from the array because it's going to change the structure. And peak is nothing but just it will return the topmost value. It'll just return the topmost value and you just print it. So maybe we can concentrate a little less on these part, but the actual idea is to show this one where you're pushing multiple variables, and then how does it come out? You push 10, 20, 30. What pops out is the topmost 30. What would be your top? It's going to be 20 once you pop it out. Okay, so that's the core concept of it. I can probably run this and show you. Yeah, so this one, it would have pushed 10. So the pointer is 0. Now 20, it has pushed 20 and the pointer is now at 1. And when you push 30, it's going to be pushed at pointer number 2. So 0, 1, 2, 10, 20, and 30. Then I say s dot pop off. The moment I say pop, what would happen? The topmost element, the one which entered last, that is 30, gets popped out from the stack. And you have 20 as your topmost element. And finally, when you print all your elements, it is going to be 20 and 10. Okay, it's the same thing that we saw in our explanation as well. So this is about array. So the key points to note here is array, it is mandatory that you say what is the maximum size of it, and you have to just keep working around on this array this way. And in array, the other advantages, now you can even say my array of first element, 1. 1 would give you the middle, like the one which is at the specific position. So that liberty we have with array. So now coming to stack as a linked list, this is something which is similar to what we saw in the previous session, but I'll quickly go through the same example, nothing different, and the same set of functions, nothing different. Only difference here is, since it's a list, you don't have to specify any maximum limit. Upper limit is not required because it's a list. You keep linking it to the specific address, to the memory address, and you just have to say the normal thing is empty checks, return true or false. Push is going to push your data, create a node, push your value, and create a pointer, give the pointer to the next, link it to the next variable. So it just keeps proceeding on that way. Pop is nothing but you remove the first element, you take the first root data, pop it out, and delink your linked list. Like remove it from your memory, from your pointer. So it gets delinked, and your overall link, if it has 5 elements, it becomes 4. Okay, and peak is nothing but just returning the data. It doesn't change your pointer, it just returns your topmost element. So this is it about the implementation. I'll probably show this. Yeah, so as we saw, it's easy to implement, but it's not dynamic. You can't grow or shrink on runtime. So you just have to define a specific value and you have to proceed with that. And the same thing, total size should be defined well ahead. And this is how it is. If I say I'm going to have a array of 5 elements, I have to tell it 5, and then above 5, it becomes a stack overflow. So whereas in linked list, the same thing, whatever we saw, you can grow, shrink, do whatever you need. The only disadvantage is something like it could cause some extra memory because every time you need to have an address and it points to the next element. So playing around with the pointers will be costly. So that is the only thing. But in reality, mostly they use linked list because that's flexible. You never know what is the range to which it can go. You have to stack it up to what range. So in that case, linked list comes handy. And random accessing is not possible. That's true. Because in array, what did we see? We saw that you can randomly access, arrays of say 10, then you say array of 2, array of 3 or 4, and you quickly retrieve that element. Whereas in this case, retrieving it that quickly may not be possible. Okay. So now all these are representations, which I could call it like a core functionality of stack. But in reality, we don't use this kind of programming now because in Java, if you see in java.util, you already have stack itself as a method. So it's easy now. You don't have to think about what is happening inside. You just declare the stack and you just say stack.pop off, push off, peek off, direct. You don't have to worry about it. But the purpose why I wanted to show that is generally we may not be thinking on how an inbuilt inbuilt functionality works. So this is the actual implementation of stack. How did they do this? So now in Java, mostly they use linked list internally, but technically we don't have to worry about it because we just have to import that method and start using all these functions directly. Okay. So yeah, coming to real-time applications. So this is kind of something which we generally think of, right? We talk a lot about data structures, stack and also, but where do they really use? Where, how do we really use or how do we, where do we come across this thing? So one example is sub-procedure call stack. So you can just imagine all these would be happening in your, at the back end. At the back end, say if you're using SQL or PL/SQL or any other Java or any other programming language, how does it know that when you call a subroutine after the lines of code that is done in the subroutine, it has to control should go back to the caller calling procedure. So we generally know how to write it in our programming language, but internally the compiler handles it using stack. So it is something like this, the best example, like subroutine 1 is there, this calls 2 and this calls 3. So what would happen? Subroutine 1 would be the first person to sit at the bottom of your stack, followed by 2, followed by 3. And the moment the lines of code in subroutine 3 is over, the last line has come, this pops out. Subroutine 3 pops out, control goes to subroutine 2. Then all the lines of code gets executed, and then this goes out, and your subroutine 1, which is at the bottom, comes in, you execute all, and your stack is now empty, meaning your compilation is done. So you would have seen that compile successfully, your compilation is done. So internally it does all these things and do it one by one, and then it will tell you that compiled successfully. So it is stack, technically stack is the only thing where you can maintain a subroutine because our intention is to call one after the other, like call one within the other, right? So that's how this works. You cannot directly call 3 from 1. So that is not our code logic. We have written this logic. It gets implemented by the compiler for us. At the moment the compiler stack becomes empty, it tells compile successfully or something. Okay, so this is one example. Again, calculator, it is, see, there are a lot of other data structures with which you can implement also, but these are kind of key things which will be easy for us to relate and work on it. So calculator, when you see a calculator, we all do this computation, right? So open a bracket, do something, and then again open another bracket and do this operation, finally achieve at some answer. So how does a calculator know? How does it do one by one? So mathematically, we would have read about BODMAS rule where you have this sequence, division, addition, and bracket. First is brackets followed by others. So similarly, this uses stack where this can even use stack where it would be like pushing the first element. Read open bracket, push it into your stack. Start then followed by 7, multiply 4, multiply, like sequentially it will push and it will start computing. As and when something comes, say, for example, I'll take this bit alone, like 8 plus 2. The stack will be having this open braces. All these elements would be pushed to the stack. 8 would come plus and then 2 followed by a closing brace. The moment closing brace comes, what it does, it will compute this entire value. it computes 8 plus 2 along with this closing bracket, which is 10, and replace 10 inside the stack. So now it will become 7 into 4 cross 10 cross 10. Okay. So again, it will keep proceeding. Multiply into the stack, push 10 into the stack. Now you have a closing braces for which you have a pairing open brace at the very beginning. So now it means that you have to compute everything. So what would be the answer? It would be 28 cross 10 cross 10, nothing but 2800. And it would pop out that computed value outside, which is 2800. Again, it will proceed, but your stack is empty. It is done. So it will display your answer. So internally, this is what calculator does. It just pushes every every element that it reads. All these single element it reads. The moment it gets a pairing braces, so we call balancing strings. So you have this brackets, right? You balance a bracket. This bracket will always be closed by the immediate closing bracket. So the outer bracket will be closed by this. So every time it happens, it computes and it pushes. Okay, so this is one real-time example of stack. And there are a couple of other things as well. So the very basic, regularly we use this undo, redo, right? Control Z and all. So how does your Excel or your Word or any other text pad or anything which has this undo, redo operation, how does it handle? It handles through stack. So every time you write, so you would have noticed this one. I took it from Excel only. So the moment you click on this, you have all these coming up, right? So this is something like you can imagine like array. So you have a liberty to click on this also, like undo twice. Instead of undo twice, you can directly click on this to undo. So I think when we say undo, what do? You type A, you edit as B and C, everything gets pushed to your stack. The moment you do undo, it is nothing but your pop operation. Pop the topmost element, which is the latest code that you type, like latest content that you type, it comes out. Right? So that's how this undo and redo, it handles through stack. And other one, these are quite common examples. Your back and forward stack on browsers. So in your browsing history, if you click on this, like, long press on this, you get all these, right? Like what all you have checked down, like your browsing history. So how does it manage? It is all managed through your stack as a data structure. So these are the things it is there. And then it will push all these, every element in an stack. So technically, the moment you open a clean browser, you can imagine it as an empty stack. The moment you type something here and hit enter, that's your first, like bottommost element on the stack, followed by other searches. And you say back, it will immediately take you to the top element. When you say back, it doesn't take you to, like a couple of websites that you visited 2 or 3 before. It doesn't do that way, right? It always takes you to the previous website which you have hit or which you have visited. So that is because it does the top and pop of it. Okay, so these are the real-time applications. And yeah, so any questions so far? Or maybe I think we have limited participants, and I would like all of you to use your chat and just type the answer for this, and will read the question together. So we have an unbalanced string now, so which is like open bracket, close this and this and this. So what character will be on top of the stack when the for loop is finished? So as we read, right, how does it do? So it reads this open bracket, pushes it, followed by close bracket, pushes it. Once it is matching, it will come out. Then it will continuously do the process. Does anyone want to tell me the answer? What would be the final element which would be there on your stack after balancing it out? You can probably ping it on chat, or you can unmute and tell me. You want to give it a try? Okay, all right. So yeah, this is your unbalanced string, and as I said, I think sure. Yeah, that's right. That's right. So this is the one that would be the right answer. Yeah. So let me go to the explanation of it. Yeah. So what will happen? It will start reading one by one. It will push your open bracket. And then the moment it reads a closure, a pairing braces of it, it would immediately pop both of it. And then comes your next braces. So it will read this, push it to your stack, and then again go ahead and read this, your square braces, read it, and then it will compare if these two has to be balanced. It cannot be, right? You cannot balance this kind of bracket with your square brackets. So it will go ahead and read your next square bracket, which is a pairing, matching of your open. So immediately it will pop both of it, and you end up having this open bracket alone. So this is how a stack would generally work, and this is the overall functionality of it. This is a very basic example that I've given. So any questions so far? Or I have one last thing to talk about. Okay, all right. Yeah, so this is one thing which I have come across. It's a very frequently in interviews or something you will face this question, like dinner plate problem. They call it. It's a very famous problem, dinner plate problem. So this one sample of it. There are a lot of other problems around stack, but this is one major one which you might see in many of it. So the problem statement looks bigger, right? So I'll just try to read down and make it simple. Just imagine a stack of plates where, we can imagine we are going for a dinner or somewhere where you have stack of plates arranged. If at all it has to be automated, what can we do? What can we think about it? So some programming has to be done behind where in every shelf you can, or in every rack, you can have 50 plates. And then the next rack, you can start having the next set of plates. So similarly, if you're expecting say 1,000 guests that evening, you need to have those many set of 50s arranged in your buffet or in your dining area. And say if it's going to be automated in the sense the moment I pick one, the robot, like it should automatically be replaced by one more. Okay, something of that sort. So how do we use stack in that operation? So initially I spoke about set of stacks, right? That comes into picture here. So if a stack gets too high, it might topple, right? So say I'm going to say 50 is the maximum, then 51, if I come with the 51st element, it would be too much to handle, it will topple. And in real life, this is how it will be there. So you have to implement push, pop, and all these things. And we just have to write a code in any of our favorite programming language to implement the same thing in reality. So this is a sample of this problem. So you say, imagine your capacity is 4, maximum capacity is 4, and this is what I'm going to do. So push of 1 is going, 1 as in the data 1, element 1, 2, 3, and 4, and you have a pop in between. So 1, 2, 2. When I say pop, this comes out. The second number 2 comes out, and then you end up with 1, 2 alone in the stack. Then you push 3, push 4. The moment 5 comes, what would happen? Your capacity is 4. It cannot handle it. So you have to create a new stack. That is called set of stacks. Multiple stacks within a stack. So you have other set of stack, the new stack coming up where you can push your 5th element. So if this is the pattern of your guests or pattern of plates, then imagine this is how the output would be. 1, 2, 3, 4 in one stack, followed by 5 in the new stack, and this entire set is set of stacks. So you have set of stacks with all these elements. So this would be generally implemented in any of your programming languages, and it's a real-time problem where you got to solve such cases. So this can get even more complex as you progress based on your real-time business needs or something. So yeah, this problem, if you try, maybe consider it as a take-home assignment and try implementing in the language, it would be the best practice of understanding the core concept of stack, because it covers everything. It covers your top, pop, your checking is empty or not empty, and you have something related to the size as well. So these are the things, and you can try implementing it both in linked list and array. And also you in Java, if you see, you have this inbuilt, you can import your util stack. And then you can directly easily do that as well. Okay. So yeah, I think this is what I had. So any questions?
So,
Hey, hey,
just one question, Pavitra. Like, like if you have any real life example of like different, either different websites or different places where the stacks are being used.
Yeah, I think website is one part. You can even imagine your browser. So this browser stack that we spoke, right? Even your Google Chrome or your Internet Explorer or any of your browsers, technically they internally manage your history using stack. You can imagine it that way, that they use stack to manage your history, browsing history. So when you install your Chrome browser, obviously what happens, your code of your, the backend code of Chrome also comes into your system, right? So for every click of button, say back, you refresh. When you hit refresh, how does it refresh? Because that's the functionality. It would have technically what is refresh? It is a button for us, but internally hitting the same URL again. So the code would be something like hit the link, hit the same link again. And similarly, if you have to use a stack there, it would be your back arrow. So when you click on back arrow, the code would be something like pop your topmost browsing history. From your browsing history, whatever you have visited on that session, it will pop it out and show. So Chrome, your browser is a example of stack. Maybe you can say that way.
Okay. Okay, great.
Hey, Ashok, you had something?
yeah, I have a question around a stack inside a stack. Suppose, say, for example, assuming my say I have three elements. The first two elements are regular elements, and the third element is a stack by itself. So at that point in time, if I try to do top operation, what will be my outcome?
You will end up getting your stack as a data structure itself on the top of your element, because when you declare a set of stack, your set of stack itself is again a complicated data structure, like complex structure, right? It would obviously expect only stacks on it. Like you keep pushing stacks. You will not be able to push a stack and then an element and then another array or something. So set of stacks would obviously mean stack on a stack. So when you do a top or pop of an element, then when you say pop, the topmost stack. So in this case, when you do, you'll end up having this entire stack. And then within that stack, you have to read through with your for loop to unlink, unwind what all is there inside the stack, and then you have to use it in your code.
So, but what if I have to take the stack? Suppose that, like as I said, like the third element is another stack. If I need to get the top of that particular stack, what do I have to do?
Got it. So that's where your actual real-time implementation comes, right? When you use array, what would happen? This entire set of stack will be an array, and this entire stack will be at position 0. Your 0th element of your outer master stack is this entire stack. Similarly, your second stack will be at 1. And now if you want to pull the third element of your first stack, then you'll be invoking like the first one of 0, and then within that, which is again a stack, and there you have to traverse through your stack and get it. So that's how it would, technically you can code. But what I have seen in most of the cases is like stack will generally be used only when you have to keep pushing in the order of their entry. Like when you want to implement last in first out, only then you use it. Because imagine this queuing system that we have, right? Which is completely different. It is like first in, first out. Like the person who comes to your hospital or somewhere, the first token gets the priority, right? So there you cannot go and implement stack. It will be completely opposite of it. So you would have seen a lot of hospitals automating their patient system, right? Where you see a lot of LCDs and they'll have the token numbers. So there, this would not suit. So technically, to answer your question, you have to keep invoking through arrays, and that may not be that possible in linked list. If you have implemented through arrays, it is possible. But in reality, people don't tend to go to a bottommost stack and pull something, because their intention itself to go as last in, first out. When I have to use this last in, first out, then they'll go for stack, so that you keep removing it from this way, 5 and then followed by this, and within this 4, 3, 2, 1. So if this is the call, as I said, undo, redo, obviously you do this, right? 5, 4, 3, 2, 1 is your undo and redo order. So that's where it will be used.
Sure, Pavithra, answers my question.
Thanks. Okay. All right.
Folks, if you have any more questions, you can unmute yourself or put it in the chat.
I have one question, like if the push and pop of set of stacks is going to behave the same way as it's going to do on the stack, so what's the use of set of stacks? We
So
can have
what
a single, yeah.
Correct. Got it. I got your question. So this example that I showed, right? This one, the dinner plate problem, it involves set of stacks because they have a limitation to every stack. So their intention is to arrange the plates in multiple sets. You cannot, if you have 1,000 guests, we cannot have all the 1,000 plates in one single stack, right? Like how do we get it? How do the guests take one plate after the other? That is very much impossible. So on an average, they have to ensure that their attendees, their guests should be able to access the plates. So based on their setup and the infrastructure, they would automate it saying 20 plates in one stack, so that it'll have multiple stacks, set of stacks of 20. And in that case, you use set of stacks because you have a limitation, you have an upper limit, and that's how their real-time scenario calls for.
From the system point of view, right? The memory it's going to take for storing all of them and accessing them, they're all look same, right? Even though.
No, okay. When you say it looks the same, can you be a little more detailed about it?
Yeah, I mean, from the system point of view, right? It's going to store them. It's going to access them. Like so initially I thought like we have to push the stack. We have to when we pop it, it's going to return as a stack. So
Correct.
yeah,
In set of stacks, it will return a stack. But in normal single stack, it will return the topmost element. So when you consider this, right, this output that I'm showing here, this is a set of stack. So for this set of stack, what is the type of element that I'm pushing? The type of element itself is a stack only, right? So this stack doesn't bother about what is there inside this stack. For this outer stack, what it all sees is, okay, I'm a stack and I'm getting a lot of stacks within me. So for this outer stack is the data element that comes in. So when I say pop, this would be the first one to pop out. The entire stack is the first one to pop.
Okay.
Whereas in your browsing history, this will not, set of stacks will not be the case. It will be normal stack, where you have your, say, google.com followed by other websites.
Okay, understood.
Okay, yeah, thanks.
Thank you.
Any more questions do we have? Okay, if not, then I think we are good to close the call, close the meeting. So this was a very informative session. Thank you, Pavithra, for taking time out. And thank you, everybody, for joining on a Friday afternoon. And I think there was some Zoom glitch, so a lot of people might have joined the incorrect Zoom. But we have the recording, and you can tell your friends, they can go check the recording. So thank you so much, Pavithra, for your time, and thank you all. Have a very nice weekend.
Thank you.
Thanks,
Thank you.
Pavithra. Thanks, Vasudevan. Thanks all. Bye.
Thank you. Bye.